Okay, here we go, part 3, Carlin Alt, and now we're going to look at our two joint reaction force components. In the Y, we had a negative 72.5 pounds, so that's going to look something like that, my JRF in the Y direction, and then my JRF in the X direction was equal to a positive 267.8 pounds. What I need to solve for now is the resultant JRF. So, right, you remember C squared equals A squared plus B squared. And if we solve for C, it'll be the square root of A squared plus B squared. So if I plug this in, my C, or my resultant JRF, is going to be equal to, I have my little sheet numbers over here, 267.8 squared plus negative 72.5, that was pounds, squared. Take the square root of that, and you should get a resultant, or a JRF resultant force, equal to 277.4 pounds. That is the magnitude of our joint reaction force. Now I'm going to go back and double check. What was my muscle force originally? The muscle force resultant was 285. Remember, this should be close but not identical. I'm happy with that. That makes sense. If I came up with a number like 700, my math is off somewhere. Now the last little component we have to do is we have to define this JRF by an angle. Here's my muscle force. Here's my JRF. This is acting on the humerus. The JRF is acting at the joint. The JRF passes through the joint, so it was never in our moment equation, but when we get to our final calculations, we know that the force is acting here and looks something like this. So this was 20 degrees. I need to know this angle of where the joint reaction force is acting relative to the bone. So if I'm looking for this angle, that's the same as this angle. So tangent is the opposite over the adjacent. So I'm going to take the inverse tangent because I'm going from the numbers back to the degrees. So the inverse tangent is going to be the joint JRF in the Y direction, which is negative 72.5 divided by 267.8. Keep the negative in there. And now if you take inverse tangent and make sure that your calculator is in degrees, not in radians. You need it in degrees. And if you take the inverse tangent of negative 72.5 divided by 267.8, you should get something that's about 15.15 degrees. So the most correct way to describe the joint reaction force is it is a magnitude of 277.4 pounds acting at 15.15 degrees relative to the humerus. Sometimes people want to describe it in a quadrant. If you tell me 15.5, I will know that you have done it correctly. Is 15 pretty close to 20? Yes, it is. Why is it not exact? Because if I go back to my original picture, the JRF is the equal and opposite reaction of all the forces acting on the limb. So the 15 pounds and the 10 pounds have an influence on the angle that JRF is acting, and they have an influence on the magnitude. So it should be close to equal and opposite, but not exactly. That's the end of part 3. Thanks.